This is the continuation of our first video about implicit differentiation. So remember, our task is to find for y prime or dy dx by using implicit differentiation. Okay, we're now going to find dy dx for this expression. So again, if you recall, the first step is to express or find the ddx of both sides of the equation. Okay. Now, if you recall, we have a function here, or we have an expression that is the result of the product of two functions, y and cosine x respectively. In other words, to find for the derivative of that, we use the product rule. Okay, so what is how do we perform the product rule? Again, according to the product rule, the derivative of y and cosine x is y, which is the first function, times the derivative of the second plus the second, okay, times the derivative of the first. Okay, and continuing on the other side, the derivative of the sum, of course, is the sum of the derivative, right? So we have derivative of x squared plus the derivative of y squared. Okay. Going back to the left hand side expression, we have y. Now what is the derivative of cosine x? We know that to be negative sine x, okay? Plus your cosine x, okay, times the derivative of y. Now, what is the derivative of y? Again, derivative of y with respect to x is dy dx, okay, plus the derivative of x squared, which is 2x, and the derivative of y squared with respect to x, if you recall, remember the derivative of y to the n is n y to the n minus 1 times the derivative of your y. So you have this will be 2y times the derivative of y with respect to x, okay, dy dx. And next thing you do is to solve for dy dx. That means that we have to put this expression together with this, okay, on one side of the equation. And doing that, you'll get cosine x dy dx minus 2y dy dx equals 2x, and then this expression is now written here as y sine x. The dy dx can be factored out. We need to factor out because our objective is to solve for dy dx. Then you have cosine x minus 2y, okay, equals 2x plus y sine x. So dy dx can be expressed as 2x plus y sine x, dividing both sides by cosine x minus 2y. So this is our dy dx. Okay. Next example. What is the dy dx in this expression? Again, we indicate the ddx, okay, on both sides. ddx of 1, and then the derivative of the sum is the sum of the derivatives. So you have ddx of x sine y plus d dx of y sine x equals, of course this is 0. You have a case here where you're finding the derivative of the product, no, of two functions, x and sine y. Also here, derivative of the product, y and sine x. So let's start with this one first. What is the derivative of the sum? Okay, we know that to be the first times the derivative of sine y plus the second, okay, sine y times the derivative of x. Okay, so that's for the first. The second now is the derivative of the first, okay, times it should be the first times the derivative of the second plus the second times the derivative of the first equal to 0. Okay, and this is x. What is the derivative of sine y? Now we're going to apply here chain rule, no? Because the argument of sine is y, which is a function of x. So the derivative of this is the derivative of sine y times the derivative of your y. Okay, so this will be derivative of sine y, which is cosine y, but we have to compute also for the derivative of y, which is dy dx. You see the difference, no? If this is x, you don't need to compute for the derivative of x. In a sense, you are computing for the derivative of x with respect to x, which is just equal to 1. But since because this is y, so the derivative of y with respect to x is dy dx. Then plus sine y times the derivative of x, which is 1. Okay, plus y times the derivative of sine x is cosine x plus sine x times the derivative of y. Again, what is the derivative of y with respect to x? That's dy dx, then equal to 0. Then solving for dy dx, that means that we have to put the expressions with dy dx together. Dy dx being common, we can factor out dy dx here, and then here we have x cosine y, and here we have sine plus sine x. The rest will be placed on the other side, subtracting both sides by sine y plus y cosine x. So you have minus sine y minus y cosine x, and finally your dy dx is, the negative can be factored out, so we have minus of sine y plus y cosine x, then over x cosine y plus sine x, which is the derivative of x sine y plus y sine x.